Hello guys, welcome back to my channel. So for today's video, I'm going to continue my tutorial on KiCAD for PCB editing. I'm going to show you how to connect rechargeable batteries to your Seeeduino XIAO MCU board, and I'm going to illustrate how you can create your schematic more professionally. And finally, you can use the PCB editor to check your board's printing setup, and then finally generating your Gerber files for PCB manufacturing. So without further ado, let's get started. So here is my updated PCB view of my previous board. So as you can see, like I've changed something here because the previous layout was a little bit complicated, and the tracks I have created was a little bit too tight, and there's not enough gap for the for safety or like for easy soldering. So I've tweaked them a little bit and rearranged the items on it. As you can see, I've also rotated the button here, and although there's a missing connection from this pin 1 to the bottom pin 1, it is not necessary to connect them because like for this button, it is internally connected, like those pins are internally connected within the button. Okay, so this actually is a pretty good PCB board that we can use for our task. But like what I'm now going to show you is to how to decompose this big, complicated schematic into different chunks or units that can be better understood by users. Okay, and so I would like to say that the first part I'm gonna decompose from this huge graph is the battery unit, because like the battery, it actually supports the power of the MCU, and then I'm using the MCU to power the other devices. So these functions here, like including the LED, the switch, resistor, and the battery, can be seen as a isolated or like independent functioning circuit. So what I am going to do is first disconnect the wire here, and I'm going to select them all, and press M to move it. Okay, and I'm gonna move it to this side so that I can better manipulate it. And since it is pretty easy, I'm just going to connect the bottom part of it to here. Okay, so there it is. And move this VCC label here. Where to move it actually? It is connected here. Okay, be careful. Like make sure that the square is on the wire. Maybe this is too tight, so I'm gonna move it a little bit downward and create a power button along the wire, and then okay. And as you can see now that this subcircuit has been torn apart from this main circuit, but we still need to connect this wire from here to the pin 8 on your MCU so we can use this battery to power it. So the thing that I'm gonna do is not to connect them through the wire, but with label. So like as I have mentioned in the last video, we can use labels to denote like which wires or sub-wires or group of wires are being connected, right? So for example, this 3v3 label here is noting that these wires connected all together, right from here and all the way down here, you can see that their names or their labels are all /3v3. So they are the same kind of wires in the same group named 3v3. So in the same time, the wire that connects to the 5V pin here, or the pin 8 of the MCU, is also or should be named or labeled as the same as VCC. So what we can do is actually pretty simple. Just copy and paste the VCC label and put it here. And then we can know that this pin is going to be connected here with the VCC label wire. Okay, so we've successfully made this thing apart from it. And then we can do something better. For example, as we can see here, there's a voltage divider circuit from here, right? 3v3 goes to the potentiometer, and it is being connected in serial with the R2, and this joint, like between those two resistors, are being connected to the A9 analog reading pin, or pin 12. So let's put them outside. Let's grab them out. Say like, okay, this pin here is going to be connected with pin 12. So I'm gonna name it. How about ADC in? Okay, just ADC in. And all right, and then we are going to delete these and name this pin as ADC in. So like that means that this pin is going to be connected all the way down here. Okay, and as we all know, like this wire should be named as 3v3 as well. So we just perhaps move it a bit longer and label it as 3v3, and there we go. Okay, and I think this is okay. Like maybe not super professional, but this is definitely easier for you to read. So I'm going to put it down here. So actually, this power supply circuit can be further decomposed into two. The first one is the power supply itself, and the second one is the LED and the R1 here to show like whether the power is being used or not, or whether the board is being powered or not. Okay, and I'm gonna leave the G and D here and get rid of this line. And then next, I'm going to decompose this active low button here. Okay, so what I'm gonna do, I'm just gonna make sure that D2 is going to 3v3, and this joint between the switch and R3 is going to be connected to 13. Okay, so I'm gonna name 13 as maybe BTN, short for button, and let's copy and paste this label here and move them out. Okay, and as you can see, we can actually move them like to make sure that they are totally vertical. And the BTN label is for this one. So there we go. We've got a pretty good sub-circuit being dismantled from this huge graph. Okay, and the same, we're gonna name this as 3v3. Maybe here, let's say 3v3 is here, right? Okay. And here is our connection between the OLED screen and the MCU, and it is connected through this bus, right, with SDA and SCL pins being connected together. So that one should be also simple, which I'm gonna just get rid of all the unnecessary ones. And I'm going to leave the ground here, of course, and 3v3 can also be get rid of. and move this 3v3 pin here, and say like this one shall be how about this? Just say like, okay, 3v3 for VCC, SCL. Okay, so I'm gonna move them here and maybe extending them a little bit. And we're gonna say like, put a new label, SDA to here. I don't like this layout. Is it movable? Okay, apparently it is not. So this SDA is not movable. Okay, whatever. SCL here, and gonna copy paste SDA to be here, SCL to be here, and 3v3 to be here. Okay, there we go. So as you can see, like there won't be any intertwined wires here, which causes confusion or anything like that. And here, to be noticed that it shall be noticed that like this pin 3 on the motor is being connected to pin 4 here for easy connection on the PCB board. So I'm gonna name them based on the pins of the motor instead of those on the MCU. So, okay. I just want to know that if this label is movable or not, or maybe not. So what we can do actually is to, first, yeah, like this. Right, so that way is better. This is better. Or maybe here, like we can just move it a little bit move it a bit outward. Right. I like this. Okay. And here we're gonna name them as motor 1, together, and motor 2, motor 3, and motor 4. And to be aware that motor 3 goes to pin 4 and motor 4 goes to pin 3. Okay. Connect them together. This might look a little bit in a mess, is because like they are all being like squeezed together, but that's acceptable, I would say. Okay, and move this one out here and say M1. I'm gonna paste it here, and M2 here, and 4 here, and M3 here. Okay, so how about move it here, make them connected, move it also here a little downward. Okay, and maybe motor 1 and motor 2. Okay, right. So this feels like a really neat and simple layout for the schematic right now, right? like only here, like for the battery controlling thing, like, it's a little bit complicated. For the rest of them, it looks fine. Okay. If you wanna decompose a little bit further, what you can do is to like grab these out and say like VCC is here and add VCC label here. So like that means like they are the same, right? So okay. And what you can do next is to use these rectangle tools here to create some subplots of it, like this way, to make sure that it means like these things forms a single unit, these one are the other, and here's that one, and there are also others like this, oops, a little bit up, and this, oops, select this, right, and can select them all, move them a little bit up, and you can use this text here to say like, hey, this is the Seeeduino XIAO unit, and name it here, and name it like, maybe here it says like power supply unit, and here is the potentiometer voltage divider unit. Move this a little bit downward. And this one is the active low button. And here is the SSD 1306 OLED screen. And the last one is X27168 stepper motor. Okay. And let's see if it will pass the ERC or like electrical rules checker. Okay, errors are here. So it says like ADC in is not connected to anything. That's because, oh yeah, because it is not here, right? And oh, you can see like there are some like disconnected things here. Just fix them. SEL, okay. Let's try this again. ERC, run. Okay, no errors, and there's only one warning that was happening before. I think it's fine. Okay. And we can also see like if it updates anything on our PCB editor. I would say not, because like we are only changing the layout or how does it look like for the schematic, but we are not changing anything for it, like the abstract or the underlying logic of that schematics is still the same. Okay, and so as you can see now, we've got a pretty good looking schematic here. I'll press Ctrl and S to make sure that I've saved it. I'm not gonna lose it anymore. And the next thing I will do here is to show you how to connect a rechargeable battery to your Seeeduino XIAO MCU. All right, so the reason for this is that, as we all know, or might be every one of us knows this, is that Seeeduino XIAO ESP32S3 actually provides its own built-in power management chip that allows it to charge external chargeable batteries, like a LiPo. Okay, so if you want to connect external rechargeable battery to it, you need to connect it to the pins on the other side, like not the front side, but the back side of that board. And there are two paths there for you to connect wires or battery power wires to it, and you can definitely solder them with hand soldering. That's a big enough pad for you to solder. And I will show you how does it look like right now. So here, this is our Seeeduino XIAO board, and on the back of it, you can see that there are lots of pads here actually. So what we do care about, where is it? Okay, here. What we care about are those two pads right here. So if you, let me see if I can put it to a good position here. It's super difficult to align it. Okay, now it's better. Okay, so as you can see, like there's a negative button and a positive icon on those pads. So it means like the upper pad should be connected to the negative end of a power supply or a battery, and vice versa. Okay, and all you need to do is to solder a wire on those pads, and that's it. Okay, because most of us will have a LiPo battery like this, and at some time we've got some like headers like this, and they can be like directly soldered on your PCB board with a through hole as a through hole connector, right? So like as the LiPo batteries we can buy are almost like this. You cannot just solder this two small pins on that pad, right? Like it is doable, but not recommended, because that would be that means like your battery will be super close to your to a Seeeduino XIAO board, and you need to solder it right before you solder that XIAO board on your PCB board, and it will bring some like trouble for your further soldering. So what is recommended is that you can have two separated wires first, like downlink wires connected to nowhere, and one of them is red and one of them is black, and you solder them on those two pads first. Okay, so black to the negative one and red to the positive one. So it's like there will be two wires extruding from the pads on this side of it, extruding out, right? And then you solder your Seeeduino XIAO board on your PCB board, but those two pads, thanks to the headers here on the XIAO board, there will be a gap being created, and those two wires can go on the PCB board and then to be soldered on any part of the PCB board if there are pads there. And those pads will create two tracks representing kind of like a wired or power bus of a PCB board. And any other devices that you want to use your external battery to power it, you can connect them to that bus wire representing the GND and VCC of your battery. So I mean, there's a lot that I've said, but like I can just show you like how to do this and build it on your KiCAD schematic, so like you'll have a better understanding of what I'm saying. Okay. So what I was suggesting was like, since this battery cell here only means that the thing you're going to be connected to the 5V pin, but right now we're not using this 5V pin anymore, because as the documentation of Seeeduino XIAO board says, if you are using a rechargeable battery with those two pads to power it, there will be no power output or input options for this 5V pin to be used. That means this pin shall be abandoned. So the first thing I'm gonna do is to abandon this pin. Give it a cross here. And this ground is actually internally connected with that negative pad on your MCU. So like you don't need to have a wire connecting from that pad to this pin. It's not necessary. but I will still leave this ground to be connected to the ground in theory. And what I'm going to do next is to create a symbol representing the connector. So these connectors here means that you are going to manually connect your pads or the pads on your MCU board through 2 wires to that connector on your PCB board. Okay, so I'm going to find the connector first. And sometimes, or like oftentimes, connectors are representing with something called, are being assigned with something named JST or something like that. Let's see if it's necessary for us to do that. Okay, I see. So since that connector is meant to be used for powering, so we only need 2 pins, or just 2 pins for it, right? The first one representing the negative and the next one representing the positive. So we need this like 1 multiplied by 2 option. And I think what we need is not a socket, because like socket means that it's kind of like a female end of a header. What we need is this pin, and it will create through, and we need to create through holes on your PCB board to make sure that you can connect wires and solder wires on your PCB board, because like for wires, they are kind of like pins, right? Like they are like the male end of any jumper wires. Okay. So let's use this con 1 multiplied by 2 pin here. Okay, I'm gonna make it like this. And right now, this power battery cell represents the LiPo battery you're gonna to connect. And if this switch is closed, you are going to connect the VCC to one end of this pin, and the other end of it is should obviously connected to the ground, right? So what I'm gonna do is to move this ground a little bit like this, create a closed circuit, and means that all the things here are going to be connected to the ground. Okay, so let me see if this is okay. Right, this looks good, because like if this switch is closed, then here like will be powered with the full battery's voltage, and like what is going to be connected between those 2 pins are the 2 pads on your MCU, but they are not directly connected to it, because like you are gonna use wires to connect them. Okay, so this will of course update our PCB board a little bit. There will be a new device to be added to your PCB board, right? So what I'm gonna do first is to assign footprint for your connector. Yeah, as I said, like these things are often being called as JSTs. So I'm just gonna see like any JST connectors with 1 multiplied by 2 pins there. And for the gap here, since you are going to solder wires on it, I would recommend to make them larger. And the larger the gaps are there in between those 2 wires, the easier you're gonna solder them, right? So I would select a 1 multiplied by 2 5mm vertical one, because it looks like this, and it should be easy to be soldered. Okay, and what's next is that, as you can see here for the LiPo battery, because this is this is the header you are going to use to be soldered on your PCB board, representing where it is representing that battery symbol. So these 2 pins gap is actually the same as the breadboard's gap between any two holes. So it means that this gap is 2.5 millimeters. Okay. So what I'm gonna do is to change this battery cells connector footprint to a smaller one, which is this one. Let me see. Is this one good enough, or are there any better ones like this? I would say 2.5. Okay, so here are the footprints that I can use. Yeah, something like this, and something like this. They looks almost the same, I would say. It's really difficult to think about like which one is the exact one I'm gonna use. I think this one looks like it the best. Let me show you. So yeah, as you can see that here's the real header that I'm not gonna use, and here's the footprint of it. Like they look almost the same. Okay, still with those two like holes on the top of it. So okay, I'm just gonna pick this as the new footprint of my battery cell. Double click, okay. And then after me going to this PCB layout, I'm gonna update my PCB again, and you can see that something has changed. I've got a new device here to be connected, which is the connector for the pads on the ESP32 rechargeable battery pads. And in the same time, my device for connecting batteries has also been changed because I've made it smaller. Okay, so lots of things to be done. I'm gonna move it a bit. I'm not confident that my previous wiring was correct, so I'm just gonna delete it. And I definitely need to reconnect most of them. So in the same time, I just want to check that I haven't added any new labels representing powers. But no, there's one new bat. Is it already there? I'm just gonna check. That classes bat 3v3 VCC GND all being created with the PowerNet class. So okay, it's fine. So what I'm gonna do is just to do this. This can be directly wired to here, but it is not recommended. I would use the node to connect any two different wires instead of using a straight line to have a new node to be created here. Like that's not recommended. And what am I gonna do here? It's like this. Does it look good? I think this one is acceptable. I will just leave it like this. And for ground here, I'm gonna create it like this, and this one will be like this. Looks good. Okay, let's go back to the schematic view and do the ERC check and see if there's anything wrong. Nope. Go back to the PCB view and inspect with DRC, which is Design Rule Checker, run. Okay, there are several violations here, so let's debug them one by one. First one is net class power clearance actual. Okay, so it means that perhaps, oh, I see. So since we are not using this pin anymore, we should definitely delete all the tracks connecting to it. And as you can see, like this pin should be connected to VCC here. So I need to, this looks a little bit ugly, but okay. Yeah, I think it's acceptable. Yeah. And right, let's check it again, DRC. Okay, so there's no violation, which means perfect. But like as you can see, like there's an error about unconnected item here, and it is pointing to this wire, right, between those two BTN wires. But like we don't need to connect it because, as I said before, internally within this button, like those two pins are the same, are connected. So this is a useless notation here, I would say, like something which is a little bit bugged from KiCAD that I think it definitely should be able to get rid of, or otherwise it would be super annoying for us to check it. Let's save this, edit, and yeah, I think this looks perfect. And as we can also notice that there are some warnings on the DRC checker. Most of them are saying something like silk screen clipped by board edge, which means that this silk screen printing will be cut because like there's an edge cut here, and these things are outside of your board, which won't be retained. And there are also things like solder mask is covering those silk screens here, like this. I would say if you want them to be kept, you can definitely reduce the size of those fonts and make sure they are not overlapping with those silk masks, right? For example, I would say, I'm gonna try, like, if it's possible for you to edit it here. So, right. I mean, it's a little bit weird. Let's see, press E, and it says like footprint properties. But how can I adjust the pins of it? Like the number of the pin? Edit footprint. Okay, this will bring up this footprint thing. Okay, I see. So the reason why it is being overlapping with the solder mask is that there's a name of those wires here named BTN, and that thing is overlapping it's causing the overlapping thing. Okay, so as long as I don't care, I think it's fine. Like those silk screen notations here are only here to remind you that you are going to solder those things on it, and those pins are kind of like correspondingly fit, right? But like for buttons like this, either you solder them let me show you in the physical real world, right? And so like remember that we are soldering this button on that side, that edge, oh no, that side of the board, right? It's not, we're not soldering it on the surface of it rather than like this. But like either you solder it on this way or like with 180 degrees rotated, they're both the same because like this is a symmetric button, like those two pins are being controlled by the button, and those vertically, those pins going vertically, they are internally connected. Okay. All right. So what I'm gonna show next is that you can use a shortcut here in your PCB editor, which is Option +3 for MacBooks. This will bring up this 3D viewer function, which is super nice for you to have a basic understanding and intuitive understanding of your PCB after it's being manufactured. And it has also automatically added all those switches, connectors, and surface mount soldering items here, right? So that's pretty good, I would say. And for Windows, it should be Alt +3, right? Because like Alt and Option means the same thing for MacBooks and Windows laptops. All right. And the next step I'm gonna show you is to create a ground panel of your PCB board to represent the ground. to represent the symbol ground. Okay, so the advantage of it is that it can make sure that the PCB printer is cutting the least amount of materials from your material, because all these wires are not they're not being added on your board. On the other hand, those things that on your board which are not in red are being cut off from your board. So your material will be like a plain copper, will be a plane with copper on it, right? And all those like places without red on it will be cut off by either laser or drill. But if you can retain the rest of the area to represent the ground, because like the ground should be all connected together. If that's the case, the machine only needs to be cut a small amount of those coppers on your board, and it will still work. Let me show you how to do this. So to achieve this, you need to use this tool on your toolbar, means add a field zone. And after you click it here, oh, it says like, now you are selecting the silk screen thing. It's not good. I'm gonna select front copper. And here we go. Now it's asking me like, which net should it represent for the rest of those coppers on the board? So as we said, it's of course G and D. I'm also gonna select BCU, even though we're not printing it. And we are gonna create a big shape that's covering everything of your board. If you want to close it, just double click, and there we go. Next, you just go to inspect and run the DRC once more. Boom, there we go. And now, as you can see, all the red here are gonna be kept, and the blue here are those tracks, or on the other hand, the non-tracks to be cut off from your copper plane. And if you check this closer, you can see that all these pins or paths representing ground are connected with those rest of the big red area, but like those representing other net classes are being totally cut off from it, right? So it means that the rest of the red means the same node or same net, which is the ground. And of course, these wires representing the ground are not gonna be printed at all, because like the electric can be transmitted like just through this big plane instead of using any like specific tracks. All right. So the last thing I'm gonna show you in this video is about Gerber file exporting. So just go to here and say like, let me see, where is it? Sometimes I'm really not familiar with those new tools popping up. Okay, let me check. All right, just came back from Googling. So like, yeah, I've forgotten what's the right function of doing that. But like every time I think that's easy enough for me to Google, I'll Google it, right? So it is here, this plot function here. So after clicking it, it will bring up this plot window. And we don't necessarily need every kind of layers here to be generated. For example, these front, backward, courtyard, and margin, they are behaving kind of like a guidance for us to guide us how to connect and route all those different tracks. And they miss nothing actually for the real fabrication. So we won't select them. And for the rest of them, edge cuts, soldering mask, skill silk screen, and copper are of course useful. So let's click plot. But right before that, please set your output directory, otherwise you might be losing it. Okay, so I'm just gonna Save it. Let me see, Gerber. I'm gonna create a new folder named Gerber. Okay. Not Gerber, Gerber. Yeah, I'm gonna select that one. Yes. Okay. So it is using a relative directory representation there. It's fine. Then we click plot, and it says done. But wait a minute. Don't close it right now, because we also need the drill files for you to drill those holes on it on your PCB board. So click generate drill files and the generate drill file. Done. Close done, and you shall see that there will be generated Gerber files in your directory. Hold on. Okay, so here are the generated Gerber files. They will be looking like this. And what's important, or what matters the most, is this XIAO Gerber file and HCAS Gerber file. Otherwise, you cannot cut your board off from the material plate. And this PTH drill file is also important because that indicates how your holes, and including drill holes and those through holes, are going to be drilled from your plate, right? Because like if you press Alt and 3 or Mac Option 3 here, you can see like there are holes, right? There are holes on your PCB board, and they're going to be drilled or being lasered out. Okay. And that's it. That's actually everything that I want to cover for this tutorial. And if you follow me step by step throughout my journey and right now, I will pretty sure that you can have a pretty good PCB board to be printed. Okay. And for the tutorials in the future, I am planning to add more PCB board and Seeeduino XIAO related coding things. For example, I'm gonna see how can you decompose a specific sensor component from a breakout board and use existing PCB files and integrate them into your PCB designing. And in the meantime, I'm also gonna try to show you how you can create your own footprint if you are using some new components without a provided footprint file, and including and something like that, including using breakout board, something like this, because like people don't provide footprints for breakout board. But like if you want to use it, you need to create a footprint by yourself. Okay, and there are also lots of things which is fun to do for Seeeduino XIAO. For example, there's a thing called FreeRTOS, which is a scheduling and operating system, which is but minor on your Seeeduino MCU. What it can do is like it can schedule different tasks with multi-thread processing technique. Then if you are not controlling a stepper motor, for example, with a driver, you can use that to control it in a non-blocking way with your main thread to control other things. So you can print as many as characters you want on your display, but at the same time, you can use another thread to control the movement of that stepper motor. Sounds nice, right? And I'm also planning to cover something about TinyML on MCU. Let's see if that's necessary. All right. Okay, thanks for your watching for all the 3 videos I've created, and happy to see you next time. Bye-bye.